Hello, ladies and gentlemen. This is Imran Malik. I'm starting this technical professional channel on YouTube, Tangents. Uh, my corporation in Southern Ontario is Simply Complex Corp. Simply Complex Corp because we solve complex problems by simplifying them. So that's the story behind. Can you guys properly see me? Yeah, okay. So today's topic I've posted on LinkedIn for voting, and some people voted. Thank you very much, whoever has voted. Both topics were got 50% vote, so I've selected project success and failure. Projects are becoming important these days all over the world, not just one country, because infrastructure is changing. Motivation for this presentation is that projects are not just Gantt charts. Do you guys know Gantt chart? Gantt chart is like a timeline of project, like with different activities around. So those are the Gantt charts. Small projects at work, you can assign resources and all that. Mega projects are failing. Failure does not mean that its performance not performing. Failure means that it has gone over budget by a substantial amount. So we'll discuss later what failures actually turn into success also. So banks, credit providers may lose their trust on the borrowers for doing mega projects, infrastructure projects like railways, like nuclear power plants, like oil and gas, pipelines and refineries, and big wind farms. And these are times of industrial rebirth. 35 to 40 years ago, even 50 years ago, there was an industrial revolution. So in that industrial revolution, there has been a lot of industry made and power plants and all those things. So that's decaying. The aging management is the key word. Plants are aging. Infrastructure is aging, bridges are aging. Along with that, major technology is shifting. Technology shift in terms of centralized control, intelligent controls. We'll discuss a little later. These are times of high changes. By high changes, I mean like if you see, I've selected the project success and failure in POP perspective. POP means project, process, organization, and product. So in that perspective, if you see organization, a lot of experienced people are retiring because their maximum working life within their lifetime is about 30, 35, 40 years, maximum 40 years. So the industrial infrastructure also ages with that, and the skill shortage. Human resource in projects are either new, either they are young, or they are diverse. All of these pose substantial challenges. The goal here is to spread awareness of managing project well. What are the vulnerabilities of the project? What are the loose ends? I myself, I'm a project engineer, project manager at a nuclear power plant. I've worked over there for several years. I've worked in fertilizer plant in Vernon, Manitoba. I've worked in SAGD oil and gas project in Calgary, Alberta. This presentation is for project man. The audience for this presentation is project manager, project directors, project engineer, technical staff, field execution staff in project with budget ranging from multi-million to $1 billion. This is not a project management course, so do not expect that I'm going to be teaching you the gates in the PMP project management courses. You can go and take all those courses. In fact, these days companies with such a large over 10 to 20,000 people and beyond, the companies have their own project management, capital projects, protocols, and decision-making framework, DMF, if you call. I used to work in fertilizer plant. They used to call it DMF. So the rundown of this presentation is we're going to discuss what project is, just briefly, for the audience who wants to know comparatively what we are talking about, not exactly what's the word deep down what project management is. This is not a course of project management. What POP is, stages and life cycle. What is variant project and what is new project? You might not heard of this, but this is not part of project management courses. So variant projects and new projects and innovation risk in them. You might have heard of new product development process and all those. Promise of performance and priority, the contract between owner operator and the EPC company or whoever is the main contractor to build the entire plant. This presentation is also from the perspective of large construction project. It's not the project of mobile products like, okay, big multi-million-dollar yacht, which I want to own at some point in time, cruising along Atlantic, so that's my goal. So synchronous change management from POP perspective, if one is changing, the impact should be analyzed that specific resource is needed or not. Sorry about that, I shook my camera. Project organization-based risks, project-based, phase-based risk, time-based risk, contingencies, burnouts, and small things become bigger. Do not neglect small things. Very high level of efficient and effective communication is needed in the project. Computers and technologies help a lot in fast and effective decision making, information exchange, but there's much more to that. Site specific risks, employee health, optimal engagement. We should have fun while doing the project, and reward. If reward is not competitive, you might end up losing experts to other companies, or other places who offer rewards much better. And this is not reward salary, it's the bonuses, it's the encouragement every day about safety issues, about initiatives, about teamwork, about technical innovation, about process innovation, about product internal intrinsic process, processes innovation. Then we're going to discuss authority versus responsibility. This is a huge problem which is in leadership hierarchy in the project, which is and can cause failures. Remember, we are discussing project with respect to risks. What are the risks? What can make it succeed? What can make it fail? Life cycle risks. We have in the beginning I'm going to talk about life cycle. Life cycle risks. A life cycle risk include aging management. Over the period of time, facility ages and at times you cannot even find the supplier for the component or equipment which fails or deteriorates. I'm going to conclude and then going to provide information on my future work, provide you contact information if you need training or need to come and give you some one-on-one trigger startup, and some initiative. You can contact me, no worries, we'll work on that. So project, what's project? We always define things comparatively. What project is not, like what it is not. It's not a repetitive operational activity. It is not that. So what it is, it's a one-time venture. It has a unique outcome. With that unique outcome, you need to define what that outcome should be. And while you're making that, be it software, be it aeroplane, aircraft, yacht, I want to own yacht, be it a farm project, making a farm, converting a 1,000 acre or 2,000 acres of land into a farm, farmland. That is a project as well. What equipment is needed, what a sprinkler system is needed, what are the agriculture machinery which is needed, its mobile or its installed capacity. So unique outcome with certain executed, that one-time venture is executed by organization of skilled people and through processes, procedures, and contracts. So again, project, one-time venture with a single specified outcome as product, executed by organization of skilled people through processes, procedures, and contracts. That's my definition. I didn't copy it some from somewhere, so copyrights reserved. POP, product, which is the outcome, organization, the people involved, process can be business process, change management process within the product can be fluid flow, can be signal flow, can be electrical flow, can be solid material handling, and all those things. So business processes are different and the product's intrinsic processes are different, but both can go under the POP's P, which is process. Stages of product, you guys already know who have done PMP and who have been involved in the project. I do not have to go down that path since I do not want it to be a project management course. There is an initiation, feasibility, needs assessment, they call it in nuclear, FEL, front-end loading, and design embodiment, decision, modularity, place, configuration, timing decisions. Timing decisions are planning of material, resources for initial cost assessment, major contract award for detailed design, construction, EPCM contract award, then detailed design completion, construction clearance gets done, site preparations. Again, I'm taking an example that as if I'm constructing, let's say, a nuclear power plant. So site preparations, detailed design updates. So between detailed design completion and the start of construction, there is always like a construction release process in which different types of constructability, logistics, and site issues are incorporated inside the design, which becomes then from design it becomes a construction work package, a work plan, safety plans and all that. Sorry. Detailed design updates, commissioning and startup. Once the construction is completed, commissioning, startup. During commissioning and startup, there is a thorough training of operations staff, maintenance staff. The documentation, design documentation is updated. The training documentation is made, and it's tested that if training material is enough for both as a reference later on and as a learning for the operation staff and the maintenance staff who are going to actually run the plant. A handover of project is not just like a window you go through or door which you go through and that's all. No, it's a huge activity. Project lesson learned and future extensions. It can be that during the project part of if there is modularity within the design and the capacity can be reduced, then it can be such that de-scoping can take place, and that de-scoping towards the end of the project can be discussed as a separate project itself, or so that once the company starts operating part of the asset, it can make enough money to actually invest in the de-scope part. We'll come on that. Life cycle. Life cycle is not from initiation to handover. Life cycle is when the concept occurred in the minds of people who were decision makers at the first place. They thought of a mode of power. It may be hydropower, it may be a wind farm, it can be anything, it can be nuclear. So the thought, when it came, a life cycle started from there, and it got into design phase, got constructed, then it was handover to the owner. From there on, the operation started, and there had been midlife extension, let's say a refurbishment, and then the asset worked for another 15-20 years, and then it was decommissioned and returned to the public. Once it is returned to the public and it's on the ground, nothing is happening, that's the end of life. So that start from the thought process to all the way to the time that the facility is decommissioned and handed back to as a natural forest or whatever the contract with the environmental regulatory authority is, or nuclear regulatory authority, or these types of authorities who have authority to say, okay, the decommissioning should look like this. So that's called life cycle. Variant project versus new projects. Variant projects are, let's say you are building an oil refinery, and oil refinery already had been built somewhere. So that's a variant project. New project is that, let's say you are building a small modular reactor which is going to produce power. The design has never been tested before. So, but as I'm differentiating between the two, variant project and new projects, there is an innovation risk in both of them. Even if it's in variant project, the site can be new, and we'll discuss that later. Never a project is completely copy paste from previous, given that the product is a site based, it's not a mobile product. Like a jet airliner can be the same, like Boeing 737 or Boeing 747 design is the same. So since it's a mobile product, it can be almost exactly the same copy. But a nuclear power plant at one place is not a nuclear power plant at the other place. Even all the performance parameters are the same. When you execute the project with the project organization process model, it's going to always have new types of risk. At the minimum, there will be different people. At the minimum, there will be new site. We're just going to discuss more on that. So, performance, priority. The EPCM and general contractor must have a promise with the owner operator about the priority. What's the priority? It's schedule, it's cost, it's what is it? It's quality. Cost, schedule, quality. It's a triangle. Many have seen that triangle, like, okay, there is like top is cost, left is blah blah blah, whatever. But the quality is a huge word. Quality can be safety, quality can be design, quality can be well-trained staff, quality can be well-documented design, quality can be stability of supply chain during the maintenance, compliance to laws, regulations, and contractual obligations. That's quality. Quality is huge. Quality is a generic word, but you have to define that in the contract. What's owners, let's say in nuclear power plant, that's what I know, that safety is the highest thing. It's safety culture is to be promoted and talked about at every single level, at human to human level, at human to machine level, at machine to machine level. Don't forget about the small things, because the small things become big. Always I say that. The promise of a priority within the trade-off of cost, schedule versus the quality must be maintained throughout the project, and that helps in a consistent decision-making strategy. Synchronous change management from POP perspective. If you overload workforce, they're going to rebel. So during the project, at any phase, if there are new things to be done, there must be since it's a new thing, it's a new pump, it's a new circuit, it's a new transformer, it's a new compressor station, it's a new well, it's a new machinery which has to be spec'd out. You should not try to keep putting pressure on the current existing resources, but first you have to assess whether a new resource is required for this. If not, can we outsource that, just so that our existing human resource is not disturbed. And for example, and a new process is required, that process can be itself be a contract of how the design will be outsourced, how construction will be outsourced, because construction outsourced is not as design outsourced. Construction outsourced, it might be of a critical equipment, and that critical equipment might later on need commissioning, and you need to retain the expertise of the staff from the vendor who has actually done construction. So synchronous change management from all the levels, like from product, if there is a change in the product, you need to see what's the impact in organization, what's the impact in process. Any of these three, if are not balanced, the project has the vulnerability of failure, because again, small things become bigger. Hiring of staff, just one wrong hiring decision can fail a small department can fail a huge organization. You need to make sure that you do not need to hire the maximum competent, the best person in the world. No, you do not need to do that, because partly you need competence based on aptitude. Does the person really need to want to do these types of activity? Okay, maybe he has like what 30% knowledge or something, but he has a good learning attitude. He can adjust. Hire them, no problem. But if he has a bad attitude and he doesn't have even a competence and all those things, so he or whoever it is, I'm not getting gender biased over here, God forbid, I'm not doing that. Organization is very important. If the organization falls apart, there's nothing left. There's nothing left. You have computers, you have buildings, and all those projects are successfully done by people, by the teamwork. So I always say, if there is some organization breakdown because of LOL event or LOT event, lot or LOL. LOL, people might be thinking that it's laughing out loud, but it's loss of leadership event, and loss of trust. Loss of trust happens when there is a loss of respect, and when there is loss of respect, it translates into loss of trust. Loss of trust fails the leadership, even if leadership is the best and all those things, very compensatory and everything. If there is no trust, there is no respect, then organizations fall apart. There is communication blockage, politics start. So how do you avoid that? You avoid by making sure that at the minimum, people have learning attitude on top of good behavior. They compensate each other. They do not make small things go and become big issues. They make big issues smaller. So yes. So and I help each other. Learning attitude and helping each other is very, very important. So if new skill type is needed, again outsource. See, do not push people. Phase-based risks. Phase-based risks are contracting and scoping risk. In the beginning, if you haven't decided correctly what you're going to do, and you know the fine details to the point that better cost estimate is done, at the minimum that the cost estimate should not escalate by let's say 80% in terms of 60 to 80% in terms of new project. It's possible. It's still not good, but it's possible to do. The maximum is 50% for new projects. For derivative projects, which are variant projects, the cost should not escalate by 25 to 30%. How the performance priorities are handled, how the decision making is consistent, how the team has performed, depends on that. Initial design is marked by selection of embodiment. Embodiment is not a detailed design. Embodiment means configuration and layout of things. If that is not clear and the small parts are missing and enough details are missing, again, small things are gonna become big, later on. Regulatory. If you have an interpretation of regulation which you haven't confirmed with the regulator, it's gonna hit you bad at the time of commissioning or inspection. So make sure that your design staff, your engineering staff, your management, and all those people have licensing people, have oversight of them, so that at any point if they are not clear what code or regulation is saying, write down the interpretation you think or the engineer or technical people think that should be there, and get a written approval, do an RFI process with the regulator. RFI is request for information, so regulatory risk. Then comes the detailed, then comes the design. So scoping, design, and again design, initial design, and that is embodiment, and you come up with the equipment list, you do the noise approvals and all those things. In oil and gas, they make the master equipment list, and they do a noise assessment through certain companies. Planning is critical, and planning is very important. Design. One last thing: detailed design require a thorough check. You need to have your design work with construction to make sure that the constructability challenges are addressed. Sometimes constructability itself needs engineering. Design, remember that the detailed design is a snapshot. It's not how you're gonna construct it. Maybe there are temporary supports required, which also require engineering. There is critical lift, which also require engineering. There are logistics concerns, which also require engineering. There are procurement efforts, which also require engineering. There are commissioning concerns, which also require engineering communication. I have seen commissioning documents here and there, and towards the end, there are steps in commissioning which are not done properly, and later on there are performance issues which come out of the project. So you need to negotiate. One of the example I can give you, that if you are ordering a package system supplier will sell you the package, will help you in construction, but once construction is done, he's gone. What about the construction of that, installation of that package finishes like a year or 2 years before the commissioning is done? How that package is going to be commissioned? How you going to have commissioning support? So these are the things you need to figure out at the purchase order level during detailed design, to say, hey, we're going to do a hold. We're going to hold your payment. Do you agree? And how much we can hold, so that later on when we need you for commissioning, or you say, okay, we're not going to hold your money. We're going to just hold for the guarantee that the equipment is there. And if we are able to do before 18 months, usually 18 months is the time period. Before 18 months, we're going to do another presentation on specific challenges of purchase orders of large technical equipments. We're going to do that. No worries about that. So planning, once the design is completed, detailed design is completed, then then there is construction release of all the PNIDs, you call it, all the drawings and everything. And then planning starts. Again, planning has to be checked within POP. Product processes, organizational processes, and the processes. So small things become bigger. Remember that. Small delays in peripheral activities can hit critical path. So you just not only need to plan, you need to shape the plan and say, hey, these are the activities by the side of the critical path which can hit critical path and become critical path, and the whole plan can go cuckoo. So predictive ability, you have to use a lot of predictive ability. You have to do planning, you have to do resource planning. So plan is different from schedule. Plan is the structure of schedule. A structure of schedule is what should happen before, what should happen after, what should happen in parallel. But schedule is that, okay, now you're gonna allocate the time. Once allocated time, then you back check with the resources, different type of resources, different type of teams, how much exactly do you agree. Then the slacks, those are the part of project management. Project management you can learn on its own, start before and start after and all those things, you know. Different plans, construction work plans, construction work packages, building packages, job safety analysis. Every work plan should be checked for the safety. And again, design is not finished at the point of design. You may need, at times, you actually may need to design a component for safety. Let's say there is a specific type of scenario in which there is a curved surface going all the way to the height. You have to design a curved ladder or a curved path to go all up there, to have an access. So then the safety requires a separate type of design. Design never finishes. Let me also, because I'm going to do a separate presentation on leadership. There's a floating leadership concept. I'm going a little off from there. There's a floating leadership concept in project management that should be exercised. That in the beginning, design has the leadership and everybody else follows. Then the planning has leadership and everybody else follows. Then construction has leadership and everybody else follows. And then the commissioning and startup team has lead and everybody else follows. But exception is that if during design, during planning or construction, if a huge change is required, form, fit, or function, that changes the intent of the design, then design leadership comes back. So it's a floating leadership concept. It's not that one is going to lead and everybody you keep following the same. Have you seen those athletes who go around on a track and they keep running and until they have a partner to start? I don't remember. And they hand over the torch to him or her, and then they run. So it's a floating cascade of leadership, and then it can have a rework where it can come back. Either design can become leader, it can take lead again. It's a continuous lead lag behavior. It's a continuous, nobody is higher, nobody is lower, everybody is working. You have to work, right? So you do not need to. And then I'm gonna just jump forward to organization-based risk. Staff availability, huge risk. Good experts. Labor disputes. Owner-operator changed expectations. They can change, but you have to make sure that you give them a change in the schedule. Given the POP, small things can become big. Communication quality and lags. If you have a contractor, if you are a general contractor, let's say you are sitting as a general contractor in general contractor like EPCM company. If your client is changing the things all the time, then you have to communicate those changes all the way. And if you have outsourced part of design, then you have to communicate that all the way to the engineering of the subcontractor. But that subcontractor needs to give their limitation back to you, back to the owner, and this cycle has to go forward and reverse couple of times. So a very, very precise and good communication is needed for timely decisions. Quality communication. We'll talk about communication later. So we have done almost half. Contingency. Financial risk and contingency, exhaustion and burnout towards last quarter of project execution during commissioning and startup. The most crucial part. The most crucial part of project is the beginning and the end. Usually middle construction, when you have already designed and everything, construction can go smooth if safety is taken care of. Construction can go smooth if safety is taken care of. Small things become big. So risk of expertise, loss of subject matter experts, due to again loss of leadership, loss of trust, loss of respect, the situational mind deactivation can take place. People can mentally deactivate if there are incompetent people surrounding some competent person. The mental situational deactivation can take place. What do I mean by that? I mean that if the similar compensation is being given to a person who is incompetent and have some had made some lobby around, some other people around who also, even if they are competent, have become incompetent due to him or her or whoever, then the person who do not join that person can situationally, mentally become deactivate their thought process. There's part of the mental health that companies should take into account. I'm just I'm going through faster a little bit. And planned descoping versus modularity in design. Again, contingency. Contingency can be a financial risk, but if the project is completely new, usually those types of mega projects which are completely new are sponsored by government, or part of that is the risk is shared with the government because it's huge, right? So part of risk management is that if the design is novel, make it smaller and make the project modular, divide the capacity. Let's say you have 4,000 megawatt nuclear power plant, you make 1,000 megawatts, or you say, okay, we're gonna make like 500 megawatts. So the modularity in design lets you do planned descoping later on in the project if you see you have such a huge challenge during design or during construction that has posed financial risk beyond 50% of the initial cost estimate, and the client is not happy with that. So again, there is unplanned descoping and planned descoping. An intelligent and entrepreneurial supplier of EPCM services, they usually do modular designs in almost every situation, just to make sure that if there is cost overrun, we at least give our owner operators something to operate and make money with until they go into profit, and then they can give us another project. Assess impact of descoping with POP approach, again for entire system of project, including products, intrinsic processes. When I say product in this situation, I mean plant, power generation plant. These small descoping, which unplanned, and small problems of instrumentation, which make system of product unobservable. Sometimes there is unplanned descoping of some instrumentation, some pumps and all those things, and due to those instrumentation you may lose the observability, the degree of freedom of the process. And I'll later explain you what are the degree of freedom of the process. Right? So once you lose observability, you lose controllability. Basic concept of control system. You lose observability, you lose controllability. Site-specific risks. Seasonal and weather changes. Huge. If you are constructing in heavy rainy area, you need to specifically train staff and logistics to make sure that heavy rainfall and all those things have minimum impact to the project schedule. Train labor available at remote places, their transport and accommodation. Fort McMurray, you fly in, you fly out, and all those things, it affects the project. Welding in low temperature, cold climate. Critical lifts in windy area, huge challenge. There are many context-based challenges, but again, the purpose of this presentation is not about the course of project management, it's more of failure modes. Employee health. Site-specific risks include employee health, mental health in projects. Safety training for possibility of human to machine safety events. Slips and trips, those are also safety events, but hitting a big machinery and getting injured, getting a hand cut, or having a leg come under some equipment, that's huge. That can stop the entire project, and the labor unions can raise the issue about that. Mental health of employee. Regular appreciation. Again, coming back, as I mentioned in the beginning, the reward should be competitive, so that an employee who is competitive can separate themselves from the people who are not so competitive. I should not use the word of incompetent. Everybody is competent in something. It's the leader who needs to recognize the opportunity in an individual person and grow with them and put them in a place where they can shine, rather than put them in a place where they continuously feel overloaded and cannot perform and become a nuisance for all other people in the group, causing a loss of trust event and then loss of leadership. So leadership and team both works together. Optimal team engagement, very important. If an employee hadn't had meeting with anybody for last 4, 5, 10 weeks, there is some problem. There is no progress. There might be issues with their mental health. Sitting alone, you need to check on them. You need to make sure that you are not alienating people based on something they cannot help with. Competence can be worked out. Your own origin, where you are from, and other parameters of your inclusion must not be an issue for you to prosper and have that shot at your career. Engagement is very important. But here is the challenge. You should not be talking all the time. Like every day or every half an hour or something, there is a team meeting. Like the whole thing, everybody comes like, okay, a big concern, this has happened and blah, 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 blah. This is over engagement. Cannot happen in project. Project is very serious activity. It's not like, okay, routine work of, okay, going back and forth between operating plant and all that. I do not have any issues with that. But you are getting hit with new issues every single day. You should transform those issues into simple language and communicate with people individually, rather than going and doing a huge ceremonial announcements of every single small thing. No, it shouldn't be there. It disturbs people. It disturbs people in a way that whatever they are doing, they start losing interest and focus on those things. So you should give them a chance of 4 to 5 days on their desk to work, and then go and check, hey brother, how's it going? Check on them. Not like helicopter check. Helicopter check means that you are doing micromanagement that can fail the team. And if team fails, department fails. Department fails, the whole thing, the whole company fails. Again, I'm going to do a separate presentation on leadership and communications. Optimal team engagement. Do not leave them alone, but at the same time, give them some time to work on their task, make them learn something, give them concentrated time so that they can actually progress and become what they are, other than doing what you want them to do. Because if they are not feeling growth does not just mean that okay, you are getting higher up in the organization and making more money. Growth means that you are learning the tools so you can do better decision making and be included in the process of the project and get recognized. Hey, this guy did that. Authority versus responsibility, very important. Authority usually have clearance to release a sum of money. Responsibility is that okay, you have to do this project activity. Until and unless, again, I have written a lot about it, but I'm going to summarize. If a responsible person, an engineer or field staff, make a decision that during his or her assigned task, and that decision leads to a financial change, but he or she does not have authority on that finance, then a communication lag will be there between him or her all the way to the level of authority who has approval, that financial approval. Remember that in project you cannot afford those communication lags. So the level of authority in projects should not be hierarchical. 5, 6, 20 levels of hierarchy. No, it cannot be like that. It will fail. It will fail the project. That is exactly why big projects, especially in government sectors and all those, they usually fail because of the huge communication from the point of where a person actually feels need of changing anything within POP or the product's intrinsic process or design parameters. So the more hierarchical the structure of organization within the project is, there is more vulnerability of failure of the project. Why? Because of miscommunication, high possibility of miscommunication, and people with egos and political interest within the company of such a high level of hierarchical structure. Maximum 3 levels of management should be able to approve $1 million to couple of $1 million changes. And if that does not happen, the projects can fail easily. Again, small things become bigger. Life cycle risks. aging management. Plant ages. Again, I've written a lot about it, and design before the release should be taking care of aging as well. If there is a unique equipment which is being made specific for the project, then the supplier should be motivated to keep that product design available throughout the life cycle, and there should be a encouragement for that. Usually the like replacements after midlife of the asset, if it passes like 25 to 30 years, it's very difficult to find the suppliers, because not only people change, but the processes change and technological advancement change. And these days the trend in the industry is that you have packaged system, packaged equipment. You have compressors, but those compressors are not just compressors. Those are VFD, variable frequency drive, with all the control system and all the shebang, so graphical user interface with the touch screens and everything, communicated with iPad and accessible on your mobile phone and Bluetooth and Wi-Fi and everything. So the trend is, without joke, the trend is basically that the specialized product manufacturers like compressors, pumps, they want because of competition in the market, they want to make sure that they give one package solution to their client, and they have electronics package and control system package for that within the component, for also to pitch safety parameters, like this pump, since it has it does not vibrate or cavitate between let's say 25% of performance all the way to 75% of performance. So they're gonna actually make the flow meters downstream or upstream such that they sense, and they have certain control system that keeps the pump running. Things like that, compressors and all those things that do not overheat, have temperature control, all of those things. So it's like the design becomes modular, and it's like plug and play. It's a win-win situation for the owner, for the EPCM company, that they just have to plug the, let's say, 9.1 megawatt glycol heater I did in oil and gas. It's a whole package system. So the thing is shifting from individual component suppliers to actually package system component suppliers. Not only the component suppliers are becoming packaged component suppliers, but also there is another level of a tier of suppliers, vendors which are coming, who procure different components and put them together and make the package system. If that component supplier goes out of business during aging of the plant, then you have a problem. The other problem with that, those package systems which come into play, is that very highly regulated critical assets like nuclear power plants. If you have those package systems, it's hard to number each and every individual components within those package system, like instrumentation, for their own maintainability. So it's difficult to have configuration management of entire plant, to have place equipment number on individual components and control systems and of that package system to be configured into the master equipment list of the plant. So I hope some of your people are understanding where I'm going, but I can do a separate. If you guys see that there is an opportunity for me to explain you something and you guys are not following, please write a comment below and I'll reciprocate. This is not a sales pitch. I'm just doing from out of my own passion, because I feel passionate about the projects, organizations which are facing challenges. So now let's quickly come down to conclusion. All the project failures have some lesson learned. So some people say there is nothing as failure. Some people say there are failures. I do not say any of them because small failures can be neglected. It depends on the contract, it depends on the priority of the owner, and it depends on owner to decide what is exactly the failure. If they stop the project and they have a loss, then that loss is loss of translates into the loss of trust. That means the next time that EPCM company might not be hired, or if it's down the line that vendor might not be hired, which is not good because there must be a learning curve. So failure, the definition of failure is not generic that there is nothing as failure. One must be optimistic, but realistically optimistic, not like optimistic that there is an infinite amount of dollar available and keep throwing over there. No, owner decides the project is failing or not failing. Remember, your client is very important. You need to make sure that you have the project's priority, the performance priority, and the criteria documented. So throughout whatever decision you are making as an EPC company, I have assumed in this entire presentation two things: that it's a construction project of a large facility like a nuclear power plant, and that I'm sitting inside somewhere in the EPCM general contractor. In conclusion, some of the main things which the title itself says: POP consideration of any change must be considered. One last thing, that the burnout happens towards the end, so there should be a team change. Again, as the design is modular, and there must be teams who are modular as well, so that you can switch the gears towards the end to bring fresh people who are ready to push the project deadline, so that the people who have burnout in the middle of construction do not slow down the project. Not that they are responsible. Remember that the project is a novel activity. It stresses out. It stresses out people faster than anything. A repetitive thing, like every day a person is going and making the same bumper of the car, the same engine they are making, it has a different level of stress. I'm not saying it's a stress, but specific in project, people have a fast burnout because they are expected to solve new things every single day. So it burns out people faster. So other conclusion is, never give up on your design team or the design team of your supplier until commissioning happens. Why? Because even during commissioning, there are things which design needs to confirm, because commissioning is test of design margins. It's not startup. I'm gonna again say, commissioning is test of design margins. It's not the startup, which is one of the scenario out of thousands in which a plant can be operated. So again, mental health and psychological satisfaction of employees must also be considered. Life cycle risks of the product in terms of the product and process and organization, in terms of aging management, must be considered. Now you're gonna ask me, what POP will be left after the handover is done that you should consider aging management in the POP model? Once the project is finished, the POP model of the project goes into the POP model of the owner and operator. That's also product organization and process. So if during the life cycle the product deteriorates, that means the organization is either not aware or they didn't knew. So there must be a specialty of aging management people monitoring everything, and they must have programs of aging management. In nuclear power plants, there are specific processes to monitor critical components they call SPV, single point vulnerability, and all those things. We monitor that. So POP of project after startup and handover transform into the POP of owner operator. So the life cycle, the aging management of that should be considered. Another aging management issue is that burnout of people in the long term who are sitting in an organization with a repetitive thing going on all the time. They had been design engineer for some HVAC, and they have been sitting for design engineer of HVAC after 25 years. It might be okay for some people, but organization, the leadership should look at like, okay, can we offer this person something better? So that's the life cycle aging management consideration of human resource to keep them engaged and excited. Site risks, local laws, and labor disputes, they can break down the project. Future work, as I mentioned, I might bring some case studies, failures of projects, examples from other. I regularly comment on LinkedIn sometimes to participate and contribute into different projects which has been done. So my plan is to do now a leadership and communication presentation. Leadership and communication presentation, especially in professional environment. What are my experiences? Remember that when I'm presenting this subject matter to you guys, I'm not claiming that this is the standard. No, I'm in a learning mode, and I like to learn. And I'm just sharing. Given the challenges of the project, the challenges of the expert human resource, the challenges of understanding of risks of project, beyond just the Gantt chart, beyond just the things which you see as timing and scheduling, and people are pushing schedule and pushing this and pushing that, and no, it doesn't work like that. You need to know what you are pushing. If you are a leadership, you are a management in the project environment, you need to know 10 times better than the person who was working under you. So you should be aware of that. Not only the technical issue, again, POP approach. You need to remember who is competent in what and who wants to become competent in what. So that not only you utilize the existing competencies of the human resource, but you also incubate and grow the competency within the organization, so that you create redundancies within the organization and modularity within the organization, so that if there is a human resource based de-scoping, which is that the part of people are leaving, that's the organizational de-scoping, if you may, there is a redundant set of people who can replace them, and project can still be executed as planned. Thank you very much. I'll display my email. Corporation. We try to simplify the complex things. If you have any challenge for me, or you want me to consult with you about some specific matter, I am available. You can communicate with me on my email. You can connect with me over my LinkedIn. I'll try to display my LinkedIn link in the about about section of my channel, which is Tangents on YouTube. I'll also display, if you need a copy of presentation, do not hesitate to email me. Anyways, thank you very much for listening. If you have any feedback for me, my name is Imran Malik and I have my corporation Simply Complex Corp. Communicate with me over the email or leave a comment just below this video. You can like or share or whatever the YouTube offers if you like to. If you don't, give me a comment. Thank you very much. Thank you very much for watching.